In this video, I'm going to review the topics that are prerequisites to calculus and that I collectively refer to as pre-algebra. And the main objectives of this review is to make sure that you understand the place of pre-algebra in the landscape of lower division math courses and know how to identify the main subject of interest and all the tasks learned in what I would refer to as pre-algebra. First of all, let's take a look at this map in which you can see that a sequence pre-calculus, calculus 1, calculus 2 forms a pipeline from the beginning of mathematics into this number of courses that we would call lower division math courses. And pre-algebra serves as a bridge from arithmetic to algebra. So pre-algebra begins and arithmetic ends with the introduction of a concept of a variable along with the idea that we can replace numbers with letters. So not all letters are variables. Some letters are called constants, and we usually use the letters such as X, Y, and Z um, to label the variables. So again, I'm not here to teach you and read you all these definitions, but I expect you to know the difference between numbers, constants, and variables. Now, it's also important to understand that we wouldn't introduce variables if it wasn't beneficial to us. So what are the benefits of actually having variables? One benefit is actually pretty important, and that is if we didn't have the ability to replace numbers with letters, we wouldn't be able to list all the properties of all operations that we've done in the previous video. So here's just an example of one. As you can see, our ability to list this commutative property of addition heavily relies on our ability to write letters instead of numbers. Now, the second benefit is that now that we have letters, we can start looking around us and we can start observing not just the properties of operations, but relations between some quantities that surround us, such as for any given circle, you can observe that circumference divided by diameter is always a constant, and we label that constant pi. So that can be expressed using the letters. Here we have a constant and a variable, and altogether it's called a formula. So again, without these letters and the idea of a variable and a constant, we wouldn't be able to do that. Now, another benefit is that we can now use our ability to write equations, and we can set some unknown quantity, observe its relation with other quantities, and we can set it up as an equation, for example. Now, equations is kind of a long-term goal here because equations is something, here's heads up, equations is something that we're going to learn or rather focus on in algebra. So what do we study in pre-algebra? And the answer to that question is the subject of interest in pre-algebra are expressions. So what is an expression? An expression is anything that you can write using letters, or rather constants, numbers, and variables, and operations, any of the 7 operations that we know. So anything you can write would be called an expression. Now, here we have to distinguish between numerical expressions and and variable expressions. So if your expression doesn't have a variable, then it's called a numerical expression. So here's an example of a simple numerical expression. I'm being creative here. I'm writing things. I'm using numbers and operations, but I'm not using variables. So this is called a numerical expression. And here's an example of a variable expression. Now I can introduce a variable, and this is called a variable expression. Frequently, we omit the word variable and we just call it an expression because numerical expressions is something that we deal with in arithmetic. So if you don't have a variable, then you're immediately taken back to arithmetic, and the only thing you can do with this expression is to compute. Now, variable expressions may have one variable. Variable expressions may have multiple variables. So here's an example of a variable expression that has two variables. It's not that hard to imagine expressions that have more than two variables. So once we have variable expressions, which we're going to refer to as expressions, that's what the main subject of interest in Prealgebra. So what do we do with expressions? The answer to that question was also given to you in one of the previous lectures. So it's not a secret that in Prealgebra we mainly focus on the following tasks. We learn how to evaluate expressions, and we learn how to simplify expressions. First, let's talk about evaluating an expression. To evaluate an expression means we are going to be given an expression. So here's an example of one. And we also have to be given the value of a variable at which we are asked to evaluate this expression. So when you're given an expression and you're given a value of a variable, there isn't much you can do with it. So we only do what we can, and that is we're going to replace that value into the expression instead of the variable. So once you do that, what's going to happen? We immediately taking from Prealgebra back to arithmetic. So to evaluate means to replace the variable with the value and to compute the expression, the numerical expression, as a result of that substitution. So the answer here is always just the number, and in this case it's number 3. Now, before we learn how to simplify an expression, or I guess we can talk about what does it mean to simplify right now. To simplify, and this is something that you have to remember, to simplify means to write in its simplest form. And you may ask, what is the simplest form? And the answer that the simplest form depends on the type of the expression that you're dealing with. So the natural question to ask here is, what are different types of expressions are there? And here I'm going to ask you, do you remember all the operations that we come up with that we listed in one of the previous videos? What are the and how many of operations are there? The answer is there are 7 operations. If you remember those operations, well, rather, if you don't remember those operations, here they are. Addition, subtraction, multiplication, division, exponentiation, radical, logarithm, and absolute value. So depending on which operation is used in your expression, we have the following types. So I'm going to start from right to left. We have absolute value expressions. We have logarithmic expressions. We have radical expressions. We have exponential expressions. So do you see the connection here? Now here we kind of lose that direct connection, but here the remaining 3. We have rational expressions, we have polynomial expressions. So how many is this? Is 1, 2, 3, 4, 5, 6, and the other ones will be quadratic. I don't know why I said 7. We have 8 types of 8 operations, so we have 8 types of expressions, linear. So these are the 8 different types of expressions, and the reason that I identify these 8 types of expressions, because down the road we are going to be working with functions, and soon you'll be able to you're going to need the skill of identifying what type of function you're working with. But guess what? The types of functions are the same as the types of expressions that are used to define that function. So these 8 names are the same 8 names that we use to classify functions. So once again, we have linear, quadratic, polynomial, rational, exponential, radical, logarithmic, and absolute value expressions, functions, and guess what? In algebra, we're going to use exactly the same names to label the equations. Now, depending on the type of the equation, we're going to define what does it mean to write that in simplest form. And let's get started. So first, let's talk about polynomial expressions. And here again, I'm just going to give you like a quick overview. My goal is not to teach you this. So if you're interested in getting into more details, just let me know in the comments below. Here we have polynomial, and you should know that linear and quadratic expressions are just specific cases of polynomial expressions. So the simplest form of a polynomial expression is what we refer to as the standard form or factored form. So given this polynomial expression, we can simplify it. Well, also to simplify means to write it in standard form or factored form. And to simplify it, we're going to combine the like terms, or we're going to factor. So here we have an example of this expression written in standard form, but you know that this expression can also be factored, right? So I'll just type it here, x plus 1 times x plus 2. So I would consider both of those answers to be one or another way of simplifying this expression. It certainly looks simpler than this. So again, when it comes to polynomial expressions, definitely specify whether you want it to be written in standard form or factored form. All right, next we have rational expression. So the simplest form of a rational expression is the one that satisfies both of these criteria. So the numerator and denominator have nothing in common, and there are no fractions in the numerator or the denominator. So for that reason, this expression is not simplified. And to simplify it, we have to what I call clear. This is actually mixed up. The bottom one is called clear fractions. The top one is called reducing a fraction. So we're simply reducing this fraction, and here's what the same expression simplified looks like. Now, this expression is not simplified because it has multiple fractions in the numerator and denominator. So to simplify it, we are clearing the fractions, and this is what the simplified version of it looks like. Now, let's talk about exponential expressions. To simplify it means that your expression doesn't have the same base appearing more than once, and there are no negative exponents, and there are no power raised to the power. So how do we simplify this expression? We use the properties of exponents, and this is what the simplified version looks like. Next one is radical. So what does it mean to simplify radical expression? That means we have no perfect nth powers inside of the nth radical. So here we have square root. So we're not allowed to have perfect squares inside. So we factor perfect squares outside of the radical. And now this is a simplified version of this. Again, I'm not teaching you this, I'm just giving you an example and kind of providing you the summary of what it means to simplify. If you want to get into more details, let me know in the comments. Now, another criterion is that we not allowed, I guess, we're not supposed to have fractions inside of the radicals because we can always kind of get rid of that fraction and simplify the expression. We're also not allowed to have radicals in the denominators, and we can get rid of that radical and kind of rewrite the expression with the radical in the numerator. Finally, we have logarithmic expressions that can also be simplified in two different ways, just like polynomial expressions. We can fully expand a logarithmic expression, or we can fully collapse it or condense it. So, for example, this logarithmic expression can be fully collapsed into a single logarithm, or it actually can be fully expanded into a linear combination of more basic logs. Now, one of the other things that we want to be able to do with expressions, along with being able to simplify them, we want to be able to perform certain operations on some of the expressions. Remember, again, expressions are predecessors of functions. And if I didn't make that clear yet, let me make that clear now. Why do I call expressions the building blocks of algebra? Because when you have an expression, and let's just summarize this. In pre-algebra, we learn expressions. Why is it important? Why are they building blocks of algebra? Because in algebra, we're going to learn equations. Equations are written like this. So every equation has a left-hand side, it has a right-hand side, and it has an equal sign in the middle. Now, if you just ignore the equal sign, what you actually have is an expression on the left-hand side and an expression on the right-hand side. So if you know how to simplify these expressions, you will know how to simplify each equation before you actually get to solve it. On the other hand, in pre-calculus, we're going to learn and focus mainly on functions. But guess what? Functions are frequently defined, when they are defined explicitly, are defined by using this notation. We introduce a function by pretty much just grabbing an expression and calling it a function. So that's why if you know how to work with expressions, you will, or it's actually contrapositive is more appropriate here. If you don't know how to work with expressions, you will suffer a little bit in algebra and pre-calculus, because expressions are used to build equations, and equations in algebra and functions in pre-calculus and calculus. And as you know, we do more things with functions. So we kind of treat functions like numbers, so we can operate on functions, so we can add, subtract, multiply functions, and therefore it's important for you to also know how to do all of that with just expressions. So for example, you should know that when it comes to polynomials, polynomials can be added and subtracted using the idea of combining like terms. Polynomials can also be multiplied using the distributive property. Polynomials can also be divided using a long or synthetic division. Rational expressions can be added, subtracted, just like rational numbers. That means you would have to find the least common multiple and then use it as a common denominator, and then perform the addition subtraction. You would also have to multiply it, and you would also should know how to divide them. The idea is you treat them just like rational numbers. Radical expressions can be added, subtracted only if they have like terms. Then you would just combine like terms. Otherwise, you wouldn't be able to add, for example, square root of 2 and square root of 3. That cannot be added. Now, radicals can be multiplied only if they have the same index or the same base. And they can be divided also only if they have the same index or the same base. Why? Because division is actually pretty much same as multiplication. Exponential expressions, on the other hand, can be added and subtracted only if they are like terms, just like radicals, and they can be multiplied and divided only if they have same exponents or the same base. Now, again, I shouldn't be reading this to you, but might as well now finish this. So logarithmic expressions can be added, subtracted only if they have the same base, using the properties of logs. Logarithmic expressions can be multiplied sometimes. Like there are some properties, but you're rarely gonna need to multiply two logarithmic expressions. So we're not really concerned with that task. However, dividing logarithmic expressions sometimes, well, not sometimes, but it's frequently done in the change of base formula. Now, there are a couple other tasks that you should be able to perform with variable expressions. And I'm talking about things like completing the square. What is completing the square? Completing the square is you taking an expression of this form and then turning it into an equivalent expression, but that looks slightly different. So for example, in this case, if I follow this abbreviation, I can complete the square by adding 1, and then this expression becomes x plus 1 squared. You also should know how to rationalize the denominator. Here's an example of how to. And conceptually, there isn't much difference between rationalizing the denominator and rationalizing the numerator. So you may not have done it before, but you should understand that processes are very similar. Now, that pretty much concludes the review of pre-algebra. Again, the main subject of interest was expressions. We frequently omit the word variable as the opposite to numerical. And the two things that we should know how to do with expressions is to evaluate, which is easy because you will be given the values for each of the variables, and you should know how to simplify. Now, what it means to simplify and how to simplify depends on different types of expressions, and types of expressions are the same as the types of equations in the future. and they are the same as the types of functions in the future. So the sooner you get used to those 8 words, the better. Now, here I'm going to provide you with the list of vocabulary that you should be familiar with, and that's it. If you have any questions, if you want me to dive in to more details for any of the topics that I mentioned, please let me know in the comments below.